Welcome back to the ShapeDiver tutorials. This is episode 7, and today we'll keep looking at some image manipulation and processing tools that you can use with ShapeDiver. We'll start by looking at the ShapeDiverImageToMesh component from the ShapeDiver plugin, and then we'll look at an example of how to combine Squid with the Make2D components to export technical drawings with dimensioning. So we're starting from the same definition we built in the last tutorial. The only change I did is that I organized it a little bit, separated inputs, outputs, and the different parts of the definition. And in particular, what we'll do is that we'll look at this algorithm that creates the Voronoi cells that we created last time, and I'll replace it with a new image processing algorithm. So all I have to do here is to copy the algorithm, so this group, and I'll work with the same inputs and outputs. So I start with the parameters of the definition and the input image, and at the end I get a new processed image, and I'll just replace the components and create a new algorithm. So this time I play with the ShapeDiverImageToMesh component, and it's a simple component that takes a Grasshopper bitmap as input and turns it into a colored mesh, so with mesh colors, where each vertex corresponds to a pixel of the initial image. So it is, in that sense, a bit similar to the standard image import image Grasshopper components, except instead of working with local files, it works with a Grasshopper bitmap primitive. Additionally, this component lets you define a number of filters on the colors of the image, so for the RGB and HSV channels of the image. So I'll construct a filter to show you how it works. Basically, every domain is between 0 and 1. So here I construct a parametric domain. And let's say if I want to filter the brightness, so the V channel of the image, I'm going to start with a domain between 0 and 1, which is the entire domain. But if I want to focus on the brightest part of the images, I can filter the upper part of the domain, so between 0.5 and 1, for example. So this is the brightest parts of the image. And if I want to only keep the dark parts of the image, I can have a domain between 0 and 0.5, for example. And I will keep the dark part. So what it does is that it only constructs vertices for the mesh around the parts that match the input filter. And the rest is basically holes. So here, if I pick the mesh, it's a bit more obvious. All right, so for the sake of our example today, I selected another image. Yeah, this one. This one is interesting. So if I don't filter it, I'll show you how it looks. So it's basically some lava. And I thought that I could use the image-to-mesh component to demonstrate one possible application of it, which is to extract contours in the image. So here, if I set a filter on the red channel, I'll be able to filter out the red parts and keep only the dark parts, which have this nice pattern, basically. So now I have a mesh that is a disconnected mesh with a lot of different parts, and I can extract the mesh edges and only keep the naked edges, so the ones with valence 1, which define the contours of all the different parts. So if I just extract these parts, we end up with those nice curves. So actually those curves for now correspond to the individual edges of the mesh. So I will start by joining them. and I'll end up with mostly closed curves, closed polylines, which I will also smooth a little bit and end up with nicer contours. So here, that looks nicer. And then I can draw the curves and create a bitmap from them. So this is what we did last time. I'll use the squid component and a draw component. I'll start from the same rectangle, and here I'll draw the curves with, let's say, an outline. Let's see how it looks like. And I'll use this image instead of the previous one. Processed image. Here. Oh yeah, I'll also define a clear to have a background color. And that's it. And if I use this also for the mug, I end up with this pattern on the mug. But now I have my closed curves, so I can also fill them, and we can create a completely different style of pattern, right? So basically I have my curves, and I can fill them with random colors, for example. So random numbers between 0 and 255. And I'm gonna build colors. So colors RGB. And what I need is to build 51 different colors corresponding to the number of curves I'm using. So list lengths. Yes. So here I end up with 51 different random colors, but they're all shades of gray because I use the same seed for now. So let's see what it looks like. Right, I have my fill with these random colors. But if I want to actually use all the spectrum, I need to use different seeds for each of them. So let's say 2, 3, 4. And here we have our pattern. Okay, so now let's go back to the mug itself and say we want to export technical drawings with dimensions of the mug, which is a bit overkill for this object, but I just want to demonstrate the feature. We'll use the following method. First, we'll use Make2D to create a line drawing of the geometry, and the output lines of Make2D, we'll just draw them using Squid on a bitmap, and on top of that we'll draw dimensions and text directly using Squid. So Make2D takes at least 2 inputs: the geometry we want to project and the definition of a viewport. So I will first gather all of the geometry I want to project, which is the mug. So all these meshes. And that's my first input. And the second input is going to be a viewport. And for this, Make2D comes with a few helper components: Make2D perspective view, parallel view, and Rhino view. Rhino view references a specific view from a Rhino document, so we can't use it with ShapeDiver, but we can use the other two. And in this case, we'll use a parallel view to draw in the XZ plane the projection of the geometry. So first, to make it a bit less messy, we're gonna hide everything else, just show what interests us. here a parallel view, and what I want is basically to draw in the XZ plane along the rectangle. Sorry, bounding box. Yes. So I'll extract from the union box, I'll extract this rectangle here, and I'll draw this 2D view according to this rectangle. So I'll deconstruct the box, and that defines all the domains I need. So a rectangle in the XZ plane, and align with the back here. So I need to extract the domain in the Y direction, and to move the rectangle in this direction. So X, Y, Z. Here we go. Okay, so on this side. And that's our rectangle. And now we have our parallel view. So it's oriented this way, so I actually need to put it in the other direction so that I can see my geometry. There we go. And now, so one note is that we have to use Make2D in automatic mode so that we get the geometry with each recompute. And if I hide the meshes and this view, and well, everything actually, except Make2D, I get my projected geometry. The next step is to draw using Squid. So it's starting to be familiar. I'm going to use the Squid component, define a rectangle, which is, let's say, the bounding rectangle of my geometry, my 2D geometry. So here, and well, I should scale it a bit actually. Let's make it double the size. Okay, and use this rectangle to draw, and to draw my curves. Sorry. With an outline. And let's use a quick preview to see what it looks like. As usual, I'll define a clear white color. And we have it. Here we can play with the parameter I did not mention yet, which is the pixels per unit. So the size of this bitmap here, by default, is going to be correspond exactly to the input rectangle, well, up to the rounded integer. And so here I have an image that's 98 pixels times 81 pixels. Obviously, that's very small, and you can't have a lot of details. So if I play with the pixel per unit parameter, I can actually resize the image to have more pixels. So let's say I'm going to make an image 5 times bigger. That's 493 pixels times 407 pixels. So here I get already a lot of detail. So that's to draw the geometry. And now we're going to add some dimensioning to this. We'll keep it simple and just draw 2 linear dimensions, the width and the height. And for that, we need to draw lines, which we'll create in Grasshopper and draw using the standard draw instruction. But for the text, we will use the text instruction from Squid. And we need mainly 2 things. We need the text to draw, obviously, and to define a rectangle where we will draw the text on the bitmap. So it's not the core of this video, so I will go fast on this part, but I created a quick cluster which takes all the geometry, computes the bounding rectangle of the geometry, and then creates exactly what I need, so the linear, the lines defining the dimensions, and also the rectangles where I want to write the dimensions. And it also gives me, well, the value, the actual dimension, which I want to write. So all I need to do is to get the two curves in both directions, and those curves I will add to the draw instruction, flattening them. So that's one thing. Now we have the lines. And for the text, I will get both rectangles, use them as input here, and draw the numbers. Okay, so now I need to fill all of the parameters of this component. So first I need to pick a font. So there's a Squid font component. And here the default, so you can pick between any font you have installed on your system. So make sure the font is also installed on ShapeDiver. Then pick a font size here. Well, let's start with 3. We'll see how it looks. Then bold or italic, underline. So that's it. Then you need to define a paragraph style. So this is just a simple component where you can define if the text is aligned left, right, or center. And also if you want to write it right to left or left to right. So I'll just center everything, both in both directions. And then we need to define an outline again, just like for the draw instruction. So I'll just get the standard black outline. And finally, well, that's it. So here, if I add this instruction, I will switch to a merge component because I have a lot of different inputs now to this instruction list. So I have my clear, the draws, and the text. Here we go. I just flatten everything, and we have our dimensions drawn. One last thing is that the quick preview component doesn't give a very good overview of what was drawn using Squid. So if you want to have more precision, you need to use the save instruction of Squid. So you can use it as the very last instruction of the Squid component. I'll flatten everything to make sure everything happens in the right order. And what it will do is basically every time the solution recomputes, it's going to bake the bitmap on your local system. So you give it a local folder and a file name. And if I recompute now, I will get the bitmap, and I can check the results here. All right, so that's it. Now, if I want to add this export to the online model, I just need to use the ShapeDiver export download, for example, as we covered in the previous tutorials. Give it a format, PNG, for example, and a name to the exported file, and that's it. So now a few things before uploading your file. Of course, make sure you are previewing what you want. So here I'm going to turn all of this off and show the mug again. All right, I need to recompute to have the actual preview I want. And something important is that you need to delete the save component here. It's going to be rejected by our servers because we don't want definitions to create new files on our servers. So you can delete it, and in practice, the ShapeDiver export component replaces this functionality online. The save instruction should only be used locally for testing. And one other point that I'm going to skip because I covered it in a previous tutorial is that this entire squid operation and the creation of the 2D drawing can take a little bit of time. In our case, well, Make2D and joining the curves takes most of the time in this definition. So you might want to add a toggle so that the drawing is only created when you need it. All right, that's it for today. Thanks again for following all these tutorials. I will post a cleaned up version of this definition under the video. So if you want more videos and you like them, please click on like and share them. And I will see you for the next tutorial.